Hey guys, again, Thuro Metal Products, Manufacturing Day 2020, Snippet 6. We're here with Bob Lotz. Bob is a manufacturing engineer, more specifically a quality engineer who oversees our APQP process. APQP stands for Advanced Product Quality Planning. We have to do a lot of validation and verification to make sure we meet specification. That kind of rhymes, before we can go into production. And in conclusion, I'll tell you how much more prevalent that's becoming, but let's get into what goes into an APQP. There's forms, there's data, and there's a process. So we're really validating a process and delivering not only a part. This is a check valve in a diesel application, but we're also not only delivering that part when we submit for approval, but we're also submitting a documentation package.
That's
so
correct.
So Bob, take it away.
All right, so we have the part here, the check valve plug. This is a drawing of the part which we get from our customer, and it explains exactly what we have to do to make the part. Gives the information about the materials, the dimensioning, anything that, if it's heat treated and that type of thing. So this is the most important part of the thing to get started, is to have all the information available to you to make the decisions you need to make to create the process to make the parts. So we start out with, when we make a job from the beginning, we start off with a traveler in our system. And this gives all the information about how to go about making the part. And it gives the information about materials. It goes through the whole process from end to end, taking the part and making it, which machine we use, and if there's any process of cleaning the parts or heat treating the parts, or if there's any outside processing such as plating, things of that nature. So this document takes the part from start to finish right through our whole system, and that is also part of the PPAP process. So when we do a PPAP, the traveler is an important factor in the thing. So we take this information and then it's documented. We start out with what we call a part submission warrant. That's part of the process of the PPAP process. And it gives the information about the specific part. We have different levels of PPAPs. There's some of them that are level 1, some of them are level 2, level 3. This particular one that I have laid out here is a level 3 PPAP, which gives all the dimensioning, the drawings, the inspection report, and all this documentation is needed for the customer to make the decision that it's an okay process to go ahead with manufacturing the product. So we take and we start off with a control plan. Now the control plan takes the drawing and breaks it down into each individual dimension. So we take the part and pull it apart basically, and take each specific dimension, explain it, what process it takes to make that dimension, what the dimensions are, the tolerances, and then we use specific types of micrometer, or it may be a height gauge or that type of thing, the instruments that are used to check that particular item on the part. And then from there we take it and it's broken down into when the part is checked, how often, by who. So in this particular case, we have an inspector check the one piece at setup, and they make the decision whether the part is correct and whether we should proceed with the running of the parts at that point. Then we have what we call a FEMA flow chart. The flow chart gives a basic rundown of how the parts go through the whole process from start to finish, from buying the materials to going to the machines, to the manufacturer of the part, to washing the parts, then they go to inspection, then they go to pack and ship. So each step is all documented out so that we know exactly what we have to do to produce this part.
And what we typically do, correct me if I'm wrong, when we submit, we don't usually give them our traveler, the customer. Is that correct, Bob?
Not always. Some situations we do use the traveler to the customer.
Okay,
Just
because,
so that they have an idea of what the process is.
okay.
And we have done that with various
Yeah,
customers.
to me, the flow chart's a simpler version of the traveler, which has a lot of our planning and our cost
Correct.
associated with it. It has some non-technical data too on our traveler or router, as we call it.
Exactly.
What is this? This is called the FEMA.
All right, so this is the FEMA, which it gives a rundown of what can happen if this particular area of the part doesn't work. So if we manufacture the part and there's this area of it that's not correct as far as dimensions go, what can take place and what the variable severity of that process
Correct.
being off, what that comes down to. So it details it out and it gives the customer an idea of what they have to keep a watch on to make a very safe product.
So let me, in layman's terms, what it does is it takes into account what's the severity of a failure. So
Right.
if a part won't assemble, it's not as bad as if it does assemble,
Mm-hmm.
but you can't detect it. And then let's say it's a steering part or an engine part,
Correct.
and it fails. So we take into account how easy, what's going to what's the outcome if it fails, and then how easy is it to detect the failure.
Mm-hmm.
When we heat treat something, it's one of the hardest things to detect, like we've gone through before, if it's hardened properly. You can't see it.
No, you can't.
If we're missing a feature such as a thread and something doesn't screw together,
Mm-hmm.
it's not going to ever get into the end product.
No, not at all.
It's not. It's going to fail assembly, and that's actually a good thing,
It is, yeah.
because ultimately we want to put our time and effort into the things that are harder to detect,
Mm-hmm.
that have a worse outcome. And there's a scoring mechanism that we go through
Right,
to determine that, because time is money,
exactly.
and we don't want to be inspecting something that has very little, that's very easy to detect.
Mm-hmm.
We don't want to,
Exactly.
we inspect everything, but we don't want to put a lot of time and effort into something that's very easy to detect if it's wrong,
Mm-hmm.
that has very little impact on if the end product is going to work or fail.
Correct.
So that's really what the PFMEA, process mode failure effect, that's what that's called.
Mm-hmm.
We have material certs that we have to submit.
Correct.
We went over the traveler.
Yeah, the
This
purchase
is,
order.
let's go over this little document right there.
This here is the statistics of the dimensioning of the parts. So what we do is we take a sampling of parts. They usually run in succession to each other.
They're continuous production.
Continuous production. In this particular case, is 30 pieces that were documented. The particular sizes were listed on the sheet. And then there's calculations that are done to come up with a number that gives you the level of accuracy of the job and how repeatable the process is. So the closer to the center line of this graph that the parts come into, the better we are as far as the repeatability of the process. So they have what they call a CPK number, and that particular number, if it's, we need to be above 1.33 in order to be in a safe zone of being repeatable.
And that's working towards what's called the sigma, right?
Exactly.
Which is it's actually detecting within a larger sample based on on the results of a smaller sample, the number of defects.
Correct.
And as that number goes up past 1, it means there's going to be less defects per 10,000, per 100,000, per million.
That's correct.
So we're able to predict a lot of the parts we make. There are parts that we make 1 million of a year. And we can't check 1 million pieces,
No.
but we can continually work our process to the point where we can predict through analysis of a relatively small group what the outcome will be on the whole.
That's correct.
And so,
So 1.33, I believe, is around a 4.5 sigma. The ultimate goal is to hit 6 sigma, which is very few parts per million. I think it's like 3 or 5 or something like that. It's very few parts per million opportunities of defects. So this particular case here, we're very centralized in here, and the CPK number is 3.19. So it's a very high number in terms of sigma. So
and what dimension, just in closing?
this particular dimension here is the inside diameter of the part.
Okay, so in this part, what's the spec? It's in metric, correct?
That is correct. This particular part is not critical on that particular dimension. It's 8.50 millimeters, and it's plus or minus 0.13 millimeters.
I know it's critical. We actually made an update to the process for production. Through all of the analysis, we decided to grind the OD.
That's correct.
Because it's a press fit. This check valve goes into another part. I think it's called a sleeve.
Yes.
And there's about 1,400 PSI that we found out through discussions with our customer, because they really were very, very cautious in how they check the outside diameter, where we have relatively little tolerances compared to the inside.
That's correct. There is very little tolerance on that.
So-
The outside is plus 0.015 millimeters. So the dimension is here. It's a 3-place decimal, which
It works out to be what's called 15 microns, which is 6/10,000ths of an inch total on the part OD, and we found it's a press fit. And again, the assembly, the check valve is under 1,400 PSI inside of a diesel engines run at very high pressure. That's how they achieve the torque. Correct?
that is correct.
As an old car buff.
That's correct.
Right, we love cars around here.
That's true.
And I'll end on that. I'll end in this. My dad, when he was 14 in 1948, post-World War II, started as a car mechanic. Bob loves cars,
Absolutely.
right? Like a lot of people in this industry did. And his boss took him aside and said, the money's not in being a mechanic and just exchanging the parts. It's actually in making the parts.
That's true.
So he was fortunate enough to have a mentor who took him out of being an auto mechanic, which could have been a rewarding career, exchanging parts, into making parts for cars and for planes and for industrial equipment, and so that's a little bit of a backstory. I'll end Manufacturing Day on that, the joy and the beauty of making parts and all that goes into it, so that our cars and our planes and anything that we buy, especially hopefully if it's made in the USA,
That's
with
right.
our quality components that go through all these checks, are working 100% of the time without fail. Bob, thank you. Thank you
very
for what you do, for helping us detect problems before they occur. That's really what this does.
That's true.
And again, the aircraft industry is really starting to embrace this whole APQP process. Bob mentioned something called the PPAP. That's the next step down term that we use, pre-production approval process. Everything we just described here is part of the PPAP. APQP requires visiting the client, understanding the application. Then it requires the PPAP. It requires approval of the PPAP package. All this documentation becomes what's called a package, and we submit the warrant, which we talked about earlier, and then that warrant has to be signed off by the customer. This one happens to be not yet signed off. It's in process, but This is all part of, you know, the PPAP package. That's part of the broader APQP process, which makes sure that we don't have to do a lot of sorting and line stoppages and things once we go live and do what's called serial production. Been great talking to you guys. If anyone wants to join me on LinkedIn, David Thuro, you can find me, a profile about me and what I love and what I'm passionate about. And hope we were helpful. Be well.